In this video, we're going to talk about building linear models from data. So when we first talk about building models from data, whether they're linear or nonlinear, we first have to have a set of data to work with. Normally, we've seen that in like a table of values, an x and a y, or some kind of independent variable and dependent variable like we see here, which is our x and our y. So whenever we display that kind of information visually or on a Cartesian plane or in a graph, that is represented by a bunch of data points, like these guys here, and these guys here. You may have heard them called scatter diagrams or scatter plots. You may have worked with them before, but really it's just a visual way to display data that we've collected or were given. Now, data is all well and good, but if we don't have a reason to work with it, then it's kind of pointless. So something that we do with data is we try to find this thing called a regression. So a regression is just a process in mathematics of fitting a curve or a line to a set of data points that we are given. So for our intents and purposes today, we're just going to be talking about what we call linear regression, or something that we call a line of best fit, which you may have heard of before. So there are a couple of things that can happen. So obviously I need to look at my scatter plot data to see if A, I have a line, and then B, what kind of line that's going to give me. So two very obvious ones are positive and then negative, right? Positive slope, negative slope. Then obviously there are ones that are nonlinear, and we will work with those later on. But if it's nonlinear, I cannot have a line of best fit. I'll have a curve of best fit of some kind. So for example, this example, yes. Here I have a negative, right, but it's nonlinear. So it's a different kind of curve, again, we'll cover later. And then if you have a scatter plot with just a bunch of data that ends up looking like it has no relationship, no line, no curve, we say that that doesn't have a relationship or a regression that we can call attention to. And now for my next trick, I'm going to insert a video here and play it for you of how to use your calculator to find the line of best fit given a data set. In this video, I'm going to show you how to use your graphing calculator to find the line of best fit given a set of data. So for this example, I'm using a TI-84. So if you have a different calculator, the key strokes might be a little different, but the process is relatively the same. So let's say I have a data table. I've got an X and a Y already to go. So the first thing I have to do is I have to input those data points into my calculator. So I'm going to press this button here, which has stat, and then I have a couple of options. So I'm going to hit edit, which is where I always edit my lists, which will come in handy, hopefully, in the future as well. So I see like L1, L2, L3, etc. So I'm going to call L1 my X and L2 my Y, and I just keep in mind that L1 is X, L2 is Y. So I enter in my numbers here. So I just chose 3, 4, 5, 6, 7, 8, 9, which is going to take a hot second for my emulator to catch up. And then in order to get to the next list, which is L2, I page over and I just type in my data values for my Y. So that's 4, 6, 7, 10, 12, 14, and 16. And again, those will take a little while to show up. But from here, I'm actually going to display it in a scatter plot just to make sure that it makes a line, because it's possible that it could make some other kind of curve. So the way that you do that is you hit second and Y equals, which will engage the stat plot list, which looks something like this. And so I'm going to hit enter into number 1, because you'll notice that it says stat plot off. I want to turn it on. So I hit enter, which will highlight the on. And then if I actually go to graph it, it looks like a normal Cartesian plane, but what I want to do is I want it in what we call stat plot view. So I'm going to hit the zoom button, and noticing number 9 is zoom stat. You notice a theme here. It looks like a line. If I take a look at these blue points here, it looks like a line. So there's something that I can do which is called a linear regression, which gives me the formula to the best that it can, that the calculator can at least, of what this line of best fit would be. So what I do there is I go back to the stat button, and instead of going to edit, I go over to calc, and then I have a whole host of things that I can choose from. So notice that I have these things called linreg for number 4 and number 8. You'll notice that it says ax plus b and a plus bx. I'm going to choose ax plus b because we are so used to using mx plus b. So number 4 is the one that we use most of the time, and that's what we're going to use for this section. So I'm going to press number 4. So again, if you have a different calculator, this list might show up a little differently, but for this example, let's just check out what this calculator produces when I click that button. So notice the L1 is my X list, my Y list is L2. That's usually like standard, so as long as you type in brand new lists each time you want to do this into your calculator, you won't even have to worry about changing these guys. So I just page down, I say yes, yes, don't worry about that thing that says frequency list. Now here's something that you can do, it's not required, but what's a cool little trick is you can actually store the equation so that way it will graph up here into y equals. And the way that you do this on this calculator is you hit, so you're highlighting here, and you hit this thing called vars. You tab over to y vars, which sounds very weird, and then you hit function, and then you just pick one of these. So I know that all of mine over here are empty, so I just select this guy. So what this says is that for the list of L1 and L2, which is x and y, I want to find the linear regression equation to the best that it can given the data points for that set of data. And it's going to store it in this y thing here, which I'll show you in just a moment. So I page down, I hit calculate, give it a moment. So what it gives you is your a and b values for y equals ax plus b. So you notice that it's a really long set of numbers here. So that's also what's really handy about storing it into the y. So you could always write this down, and then you page over here, and your equation is written out here for you. So if I actually go to graph it, there's my line of best fit according to the calculator, which does better math than I do. So what you could also do from here is you could go second table, or second graph, which gives you the table. So this corresponds to the stored equation, that really long one, into the y equals. So if you were looking for like x is equal to 1,000, you could actually find that without plugging it into the actual equation that was given to you. All right, so that's how you do that on this calculator. If you have any questions, we can talk about that in class, but that's generally how you do it. And with that, that's going to do it for this video. Thanks for watching.